in Barcelona, Catalonia, since 1982. Also, is full professor since 2006, and is one of the most influential professors of the world in artificial intelligence. Yes, of course. And of course, a friend of the Latin American collaboration. He is the former coordinator of the international relationship in Barcelona Supercomputing Center. So thank you very much, Ulises, to coming.
Thank you. So thank you everybody for being here. Thank you for the organization for inviting me for the 4th time. So I started giving talks here pre-pandemics, and was the aim, was Mateo's aim, to try to create bridges between AI and high-performance computing. And yeah, this conference has been evolving over the years. And when I was preparing this, my daughter says, well, you need to improve it, because people in the audience will be younger, so you need to change the discourse to bring it into more, let's say, Marvel style, right? So we create a new superhero, because basically what people tend to do, first to create anthropomorphic versions of the uses of AI, and now people start believing in the superpowers of having artificial intelligence on their laptops or their mobiles. Of course, we have Sally Albright. The name is perfect because it's her name on the film, Sally Albright, that met Harry, that is an experimental AI avatar. And well, meanwhile, in experimentation, she suffers an accident, and because Mateo is now super fan of quantum, she becomes Quantum Mind. And that's the origin, it's the abstract of the book created for Mateo, for a friend of him, Dan Brown. So you see the lady in the back? The lady is the mother of the director, right? And that's the most famous quote of the thing, but that's created without AI. So, and of course, Mateo, for his center, is looking after having artificial intelligence as the main flagship driving the research. A bit of context, my research is divided into two groups, one at the university and the other at the Barcelona Supercomputing Center, and was Mateo's idea to create in 2017, established in 2018, a group with 2 persons, right? My student Darío Garcia, who was keynote in Cartagena, and myself. And well, now, just before I came, we were 25 persons, and because a new set of scholarships that Mateo explained yesterday, at the end of the year, we will be 40. So yeah, we grow more or less. So we have 7 researchers, 2 visiting from the university, 12 engineers, 8 students. We got it around 3 million euros in this time in competitive fund, and then private collaborations. I will explain some of those. And what is important is 50 papers, journal papers, around 2,000 citations, 2 PhDs, and plus 10 AI master theses. So that's an idea. And this is what Mateo presented last December as the results of the center. And this is the AI. So there are 80 researchers. So just before coming, we were a third of that. We create some of the AI models, like half of them. We have only 3 datasets related. We have around half of the papers, and yeah, we contribute largely to the project. So we are a small bit in the group. So, but basically the thing is that it's clear that there is a change in the way we do research on AI. And it's not because science is developed to use a lot of resources, but big companies have started to invest heavily in creating new uses of AI. And now we have a very strange confusion in the border of research and applications. Most of the things that you see on the papers are just applications, and the amount of research there is very, very, very small. On the other hand, plenty of tools that are created in this period are helping a lot to develop new tools. So more in a different way of the American way of doing research or applications. In Europe, we are proposing to have more than interdisciplinary research. We are looking for transdisciplinary research. So groups of people that learn different languages work together to solve common problems, because it's not that someone comes with a problem, but I get into that problem. And I will be talking mostly about deep learning training, because it's what is more on the vogue, but it's not my specific research field, right? So it's clear that high-performance computing is proposing new ways to solve old problems for the AI community. So just to give you a glimpse, the first neural network was built back in 1956, was created on hardware with only 9 neurons. Each one of them was half a kilo, right? Now we have millions of those, but it's the same problem. Now you have more capacities, as Professor Valero used to say. We were a community that was in a closet, and thanks to our high-performance computing, we were out, and now we are showing off all our feeders, right? But one of the issues is that now we have spaces of search that are very large, huge, and we don't have means to understand what is going on there. And that's an issue. So we have to understand whether what we are producing is scientific research or just a coincidence of the optimization of parameters. It's more alchemia than research, right? And the other problem that arises is that more and more we have more complex data sets. We saw an example of heterogeneous large data sets, but in the opinion of people in Google, the data set we saw this morning is a small data set. It's really not big. But clearly, the synergy will bring us to solve more and more complex problems, right? And then, by side effect, we are driving innovation in different scientific areas. Well, what's happening, that's good news for the vendors. Every 6 months, you need double the amount of computing you need, doubling the amount of storage you need, right? And this is more or less what has been on the last years an evolution of models. We can see it in another way. So how much data we produce as a society all over the world. So it's all that data. So as a society, we are prosumers. We are producing plenty of data and consuming more data. And the problem is who is doing what with all that amount of data. And of course, again, all the disks required to have this and have replication, this is an enormous amount of resources that are involved there. And yeah, you can have it. Professor Mateo has one of those watches on his wrist, and it's almost a computer, right? So this is to give you an idea how, I don't know, I won't use the word. So it's very strange to try to see a society that is producing all those different models, right? This is 23 large language models, and that's 24 large language models. So do we really need all those? And of course, remember, those that are successful are there. And we believe that only a tenth of the models that survive, so only a tenth of the models survive. So there is 90% of failures there. So I don't know if that's a very good idea. Let us put it in another way. So if you count all the models that have half a trillion parameters and add it up, you arrive to 16.3 trillion of parameters altogether. And you know that more or less to train 1 trillion parameter model is about $1,000 million. And that do not include the cost of water. You give me those dates? Yeah. But 1 trillion requires 20 trillion tokens, right? And there is not enough new information to serve all of those models. So then you have highly redundant efforts all over the world. And remember, 90% of those are created in English. So all the models will produce bias for global North English WASP societies. So nothing to do with Latin American countries or African or Asia, right? The other thing is that we don't know which is the cost to curate the data to train one of those models. And the only thing that we know is that the Chinese approach is to have 2 different models, than the one that is just has everything, and one that is small but highly curated. 2 different approaches. So what about transdisciplinary research? So this started as a small contract. So there was a group of physics from ETH Zurich that wanted to estimate whether they were using beams of electrons, and they want to know where they will be impacting over a surface, right? And you have to count and then predict where will be the next and few things like that. So we started doing that, and now we have an European project that emerged from that. So now we have a line of research of trying to follow one of these electrons and try to estimate where within a surface it will arrive. And the other is the things that we've been doing in medical image with different hospitals, right? So that one is for fractures, bone fractures. So in Spain, 90% of all X-rays are not informed by a radiologist. They are not. So now what we are doing is produce a semi-automatic inform that will support the clinician to make a better decision. That one is for retinopathies. It has 2 different, we've been working on that for several years. Now we have 2, one for Spain and the other for Jalisco, Guadalajara. But the main idea was a work promoted by Lenovo, because at that time there was a senior officer there, and he wanted to solve a problem in India. He was from India, and he wanted to help ophthalmologists in India with only taking a photo with your mobile and make an analysis, and then if there is to make a screening, and then if needed, you go to the hospital. The other is a more complicated one that we do it for free, pro bonus, is to try to estimate in vitro fertilization which among all the cells will be the one that you will be implanted in the woman to be a person. So you have to estimate, because mobility and other characteristics, which one. And this is very interesting because it's our first approach to mix deep learning with traditional AI. You cannot do it just by watching the image. So we are fostering new collaborative research paradigms, enables cross-pollination and new methodologies, right? This is, Mateo took also this slide yesterday and showed it. And what basically the main idea is to train a large language, a foundational model. But the idea is the following. You train it with images, and then you mark a small part of it, and you make questions like this, right? And then the main idea is to locate the place and give explanations, right? It's not meant for doing diagnosis, it's meant to train clinicians. So when they are preparing their examination, you can do that, and you can produce it for many languages, so that will be very easy to do it. That's new. Up. So there is something that Mateo loves, that is this idea of technological integration. We have more and more the creation of specialized hardware, but then you need to know the nature of programs. One of the largest issues with deep learning is that mostly all the users and all the programmers do not know anything about programming. They come from other fields. So they don't know anything about memory consumption, optimization, and other things. So it will be very complicated to help the people in the design to optimize if the programs are already not optimized, right? I won't go this because it's too large and I have small time. So we have plenty of data. Now we can use the data to do data-driven scientific discovery, right? So we have plenty of data. We have plenty of data, and the thing is how we decide which is the good part of the data that you have to do to make a new experiment. There is an initiative that Professor Valero explained yesterday. Is the one of the 1 trillion parameter project with Riken, Oak Ridge, and ourselves. And one of the issues is which will be the sources. And we had a first discussion about that, and I said, none of the papers on arXiv can be part of the training set. It's material that has not been rated by another human. It's not peer-reviewed, so that cannot be there. We are enhancing traditional simulations with AI-based techniques, but not only deep learning. So there are techniques like case-based reasoning that will allow you to identify cases that were used before, and you can take the stack of that case and use it as the basis for the next one, right? One of the main problems with scientific data is the one created by synthetic creation of data. Right? One of the things that I found more perverse on all these companies that are producing what they call generative AI is that when they produce an image, they don't put a label saying this is AI created. And if you use that to retrain a system, then the information you are putting in will be, you cannot assess whether. If it's an image of people, well, yeah, it has a pass. If you are making it for medical synthetic data, the case won't be the same. So what we are doing now is to try to identify which are the patterns of creation in many of those programs, and then identify whether the image you are dealing with is synthetic or not. And we have to do that. So we are becoming a sheriff of the internet because, well, these big companies use anything that is on their hand to put it inside because they are looking always for data. And of course, that is in accordance with the AI Act. Right? We want to produce, let's say, data that is, well, legal to be used in, for example, clinical trial. Today, I didn't read it. I learned that OpenAI and other companies are starting to prohibit the use of some of their newest tools because the AI Act. Because there will be, let's say, illegal. Their use will be legal in Europe, so we don't give access to Europeans. Well, that's the price of being legal. What about data quality? So this is a very simple example that we use to explain kids what is data quality. So you have Le Petit Prince, the original one, and then you have translations of that. How equal they are. Which is the quality of the translation? What about translated from French to Spanish and then to Portuguese. The copy will be good. So it happens all the time. And when you use machine translation, automatic machine translation from the tools, you know that it's biased. You are producing text, mostly in scientific papers, and those scientific papers then will be read by young researchers that will be copying misinformation from the translation. And then we have a large problem on that. How many of you use any large language model to produce text? Well, welcome to contribute. So, and that will be more and more complicated because someone creates a paper and then makes a copy. I'm a member of the European Association of Artificial Intelligence. In October, we're having the European AI conference in Santiago, and we multiply by 10 the number of submissions. And now we have to implement machines to decide whether the text has been produced by a machine or by a human, or is an hybrid. So that's an issue. And we are responsible as a community to produce our own papers. I know that there is an aid, and someone told me this morning that it helps to do your homework. Well, yeah, but in research, your homework has to come from here and not from a machine. The other thing that we have to say is that data is not the new oil for the economy. It should be like water, right? From all of us that came from a country with oil, we know that you have to go very far, drill, so like in deep sea, take the oil outside and make a raffination, right? And then you have many subproducts. It's very expensive. But what we need is that the data should be clear. We need to trace the origin of data for many reasons, right? And that's one of the things that we have to face. I had a discussion in a panel with the Microsoft representative for Europe. And I said, well, I'm a civil servant. I cannot promote the use of ChatGPT because that intrudes into the copyright laws. And she says, well, in America, no. Yes, but we are in Europe. So the problem is that there is a lot of citizens that are not aware that the use should be illegal, right? So some ethical and societal consideration. So it's clear that this guy is thinking and not using ChatGPT to produce his work, right? So there is plenty of places where the mixed use of high-performance computing and artificial intelligence is creating a lot of disaster, right? So there is problems with philosophy, there is legal problems, social problems, environmental issues, right, as we saw. Then data privacy, security, cybersecurity. We have the ethical use of AI-based technologies. That's a big problem today. And then, well, the conclusion is that we need new governance frameworks, right? So this is trustworthy and American, right? So even the United States is trying to create their own blueprint to make trustworthy AI. It's a big issue, right? The slides are there, so you don't need to read it, but you have to know that even the Americans are trying to do their best. If you see this, you should be protected from abusive data practices, right? And they recommend you do your own protection. You know, this lady was CEO and OpenAI, right? And that statement is something very strange. For her, most of the creative jobs should be disappearing because maybe you don't need it at all, right? If you use Dale to make your own images, well, you are taking the job of someone that was trained for doing that during many years. But yeah, reality is very cruel, and that was in June. In September, she resigned. So maybe her job was not needed from the very beginning. So with all that, we are facing this to warm or not to warm the earth, right? So we need to know. I believe that it's a very good idea to have large language models, but public, not private. We need one, but not many. And we have to regulate the use of this tool. The Americans said a fool with a tool is an augmented fool, right? And we are creating a society that is using the tools without knowing exactly why, right? So this is last year's data. So all the supercomputers in the States declared 100 megatons of CO2 emissions. That's large enough, right? And they don't consider the water. Remember that now they are putting outside the United States all their data centers because they are trying to move, so they are greening their, yeah, I know. They are greening their own countries, right? This is another challenge. That data is good data. Just for China, in the next 10 years, they will lose around 72 million works and will be replaced by AI-based tools. The other thing is that we have plenty of laws. If you don't know the law, nothing excuses you for not accomplishing the law. And I know that Microsoft has plenty of money to break the law because they will pay the fine 5 years after. But the worst thing is that we help them to do that. And, por favor, ¿lo puedes ejecutar? So, in reality, what Mateo wants is to have AI in his life, and he's looking for a partner, and we AI are looking to have him there.
She and I, we are not built the same way.
We can have it altered.
Yeah, no, you don't. That's good. I'm good to level with you. We can't get married at all.
Why not?
Tú eres la mujer.
Doesn't matter.
I smoke all the time.
I don't care.
Se sabe muy favorecido.
I have a terrible past.
Entonces,
For 3 years
en el
now,
fondo,
I've been
si uno
living
hace una relación de largo tiempo, no importa que él no sea una mujer. Vamos a hacer negocio. Ha salido de...
Adopt some.
But you don't understand,
Sorry.
Osgood. I'm a man.
Well, nobody's perfect.
Thank you very much. Now you know the good uses of AI.
Thank you very much, Professor Luis Cortés. So, some questions? Please. The micro, please.
Thank you very much. In your opinion, is AI the new HPC? And then, what's going to happen with AI then? HPC, once you introduce quantum computing as a normal. You mentioned quantum computing. So,
Wow. So no, we are hoping, the AI community is hoping for a third winter. Because most of deep learning is clearly not AI. Is clearly cybernetics, because you are just looking for patterns to control processes without understanding the process itself. So that's not AI at all. Quantum, I'm following my leader, Professor Valero, and he says that he will never see quantum computing doing as high performance computing as today. I have to follow the leader.
thank you.
Hi, thanks for the talk. what I want to say is more a comment than a question. It's because you talk about the models that detect the synthetic content. So for that, I read it, that there are content created for people that are not English speakers that are detected as that is a synthetic content because is a bias that there are on it. Something like, well, there are a lot of bias in generation of the images and also on text. Yeah, but there is a comment about the things that you say. It's not a question.
Okay.
It's only a comment.
Okay, good. Thank you.
Another question?
Thank you for your talk. You mentioned that probably we need the tech when content is generated by model, but in some cases with not native speakers normally use not for generate ideas, but for improve the language or the redaction. In that, I believe that the future probably all the people will be use this type of tools, but in the sense of the ethics, what is your opinion about that trending?
So Grammarly already detects if the structures that are in a piece of text are created by a machine. So now we know which are the bias and the most preferential structures that the generators create. So now we know that. The problem is that the idea of originality in a text, someone has a limit, and if you have 25% of new text, that's original, right? So and that's creating a lot of problems, really a lot of problems. And then now there is a trial, a test, that's a very interesting test, that you are producing artificial articles, created by a machine, and send it to reviewers to see where they are able to detect the styles and the errors that are inside. And that's making a lot of harm to the system. And of course, archive is one attempt to avoid all the peer-reviewed systems. So you have plenty of Meneses during this time. As a matter of fact, in November and December, I'm running a course in Barcelona, and the question is, does truth has a future? Who is interested in truth? To whom interest? And without critical thinking, it will be clear that no one is interested in knowing the truth. And that, and we are creating that with machines.
Una pregunta por acá. ¿Crees que eventualmente si, digamos, esto evoluciona y llegamos a construir una máquina que replica, vamos a decir, casi equivalentemente las funciones del cerebro humano o de la mente humana, esa máquina llegaría a tener conciencia?
No, no la vamos a llegar y no.
Okay.
Okay, for one last question, please. There.
Thank you. A little question regarding the creation of AI-generated content, regarding especially like the last, let's say, 4 or 5 years. The amount of AI-generated content has like skyrocketed with Carla and other, not only image generating data, but all sorts of generated data. And I know about the degradation of the models because training AI with AI-generated data results in what I remember vaguely for like my early 90s childhood, the VHS. When you copy a VHS from a VHS, it gets weirder and weirder each copy. But the main question that I have is how in this like 2024 with all the bulks and loads and hundreds of thousands of data, could we possibly separate this data and preserve the human data for either research or...
Today it's almost impossible.
Yeah.
So just think in this mental experiment. You have a glass of water that represents a web clearly curated system. And you have a glass of wine, right? That is obscure thing that someone created. And you pour stars wherever you want. You get a spoon of one of those and put it in the other, and then do the contrary and start thinking, right? So the water will be degraded more often and often, and the other will never get clear. So by now, most of the web pages are completely degraded unless you are creating your page from, let's say, exchange materials. But that's very expensive to create and avoid bias. And yeah, we are that. Just regarding Dale, there is something that is very interesting is that it's clear that the Getty Foundation will win the trial against Dale, and they have to take out 12 million of images that they took from the Getty photography fund. 12 million. So it's clear that they were infringing property law. And you know how they were discovered? The guy who was feeding the machine forgot that each one of those photographies had a watermark. So when they reproduced Madonna, there was Getty Foundation there. So yeah, but they have plenty of money. They will pay. So.
Okay.
Thank you.
Okay, thank you very much, Professor Ulises.
La foto. Yes. No. ¿Sí? ¿Aquí? ¿Una para ti?
No, acá.
Aquí. Me llevan aquí. Allá una chica. Viene la chica.
So now we start the next session. Luis Martin, please.
Marcio,
funciona.
¿usted está escuchando? Mas tenta falar.
¿Les escucho bien? No
Sí.
sé si me escuchan.
Sí, sí, perfecto, perfecto, perfecto.
Vale.
¿Tienen agua? Well. ¿Está con eco? Está, perfecto. I don't know which language to speak anymore, so sorry. Well, welcome and to this session on the role of HPC in Transformer Latin America from a leadership perspective. We have here Nicolas Cánovas from AMD. He's the General Director for AMD Latin America. Welcome. We have Santiago Cardona from, he's the Director for Spanish-speaking countries in Latin America at Intel. And we have remote Marcio Aguiar from NVIDIA. He's the Director of Enterprise Sales for Latin America. Saudades. Sorry. The idea here is actually it's a good continuation of the previous discussion, and the way I see this is we have a lot of dichotomies in AI and HPC, no? And these trade-offs between openness and closeness of resources and all of that. So let's go around, and I think that now as we have time to discuss, and also maybe if anybody has a comment, it's also welcome. So I propose you that I throw some topics and we briefly discuss them. And the first one has to do with, well, openness versus proprietary. How do you see the impact or the connection of this in Latin America? I propose you that as Marcio is far away in the academic tradition, the person that is further away has the priority to talk. So Marcio, if you want to start.
Well, first of all, thank you for having me here. Unfortunately, I just got back from California this morning, and I'm back in Brazil. So again, the HPC industry for NVIDIA has been one of the main ones. It's within our DNA. We do have a lot of proximity to the academia, to all the national labs. In Latin America, it's no different. You know, we do have a lot of our projects that are created in the academia, and a lot of our customers that are now in the enterprise world are longtime partners of NVIDIA. We have in the region a little bit over 200,000 developers that are actively assessing our developers program, the Deep Learning Institute program. And again, we have the luxury to be one of the main suppliers for a lot of the main national labs in the region. So again, for NVIDIA, we take the higher education research vertical as one of the main ones, and that's how we are able to form new professionals, new engineers, understanding how to work with all the open platforms that we have. But as you guys know, NVIDIA is known for optimize all the open frameworks, design SDKs and APIs, and have that available to the entire developers community.
Thanks. I mean, this is a very important topic because, of course, all these there is always this trade-off when you use technology that you can get locked in the technology, even if the technology is open source. So because you can also get locked in if you use, I don't know, TensorFlow versus other technology. So how do you, Nicolas, as you are the further away now, how do you see? Maybe you can hand the mic.
Okay, thank you. Again, thank you for having me here. It's great to be here again, personally, and with AMD, another edition of Carla. Well, we have at AMD a very clear philosophy and ambition. We promote and we believe in open source, open standards. And it's not only with this recently, it has been historically, and we think that working collaboratively with a broader ecosystem brings a lot of benefits. I mean, it accelerates and improves the innovation process. It promotes competition, and we are a good, let's say, example of how competitions can bring companies and solutions on a faster innovation process. We have seen industries where the competition is low or not very aggressive, and we've seen those innovation process going slower or longer, or even having an impact in the cost. So definitely it impact cost as well. It opened to flexibility. And at the end, I would say that being here in Carla, it also helps promote that interoperability among infrastructure. That is something that by talking and the idea and the objective of these meetings like Carla, where a lot of people from the region joins in order to think what are the trends, what are the next waves, what are the new technologies. I think it's trying to find that, being easier to access to those technologies. And at the end, it's I would say it's a deeper question that we can ask, is understanding and acknowledging that AI is going to be, and is already, such an important and power technology that will probably, with HPC and all the solutions we can bring here, give answer to one of the most important challenges from the humanity. Is that should be belonging to one-on-ones, or should be something really easier to access? At least I think we as an industry need to work on that. We are trying to promote that. We are trying to bring that scenario. And I was reading an interview of our CEO, Lisa Su, that had with Time magazine, and they asked her what on top of the solutions and the hardware that AMD produced, what are the benefits or the value added? And she said that we are good at working on doing partnerships. So I would say we have a clear idea on promoting open source collaboratively with the academia, with other consortiums, with the different software development. So we're trying to do that really hard.
Thanks. Santiago.
Now I'm the closest. So first of all, thank you for inviting us here. It's our first time here in Carla, so thank you for having us. And talking about open platforms, I think Intel has a very strong track record on promoting open platforms, and I have two specific examples that have changed the industry. One is the PC. Even though it's an HPC conference here, PC was used to be a closed ecosystem, and Intel came and opened this for many companies and vendors, because we believe in open platforms. That's one. The other one is data center. Around 20 years ago or so, the data center was dominated by proprietary, closed and absolutely close standards. So Intel came and changed that, and now it's very open and universal. So we have a track record there, and some things that we're doing right now for specifically this the HPC segment is we have the One API platform that's available for developers. It makes it easier for developers, because if you wanna do code and eventually put it in a CPU, GPU, even an FPGA, you can do that with One API. So we give the developers and the ecosystem the possibilities of with just one tool doing this for many different platforms. That's one example. Another industry example. Right now, there's with all the everything that's happening with AI, there's a movement about how to make this open. I think in particular HPC is probably one of the segments that's right now probably more closed, and we want to help that to be much more open. And there's the Open Platforms Ecosystem Alliance, which is composed by many vendors. I invite you to go into the website. It's opea.dev. You can do it right now if you want. It's composed with multiple vendors, and Intel is one of the leaders there, because we want to make sure that everything AI and of course correlated with HPC is open. So Intel, I think in what I'm trying to get to is Intel is a company that has been committed to openness, open standards, open source, open computing, and of course in HPC is an area that we want to make even more effort.
Thanks. By the way, if anyone from the audience has any comment, feel free to, interject. But I think this is. I always say, when talking about AI and all of that, that of course there has been new science that has brought us here, new hardware, but also new culture. No, very few sciences, except for computer science, have created this culture of sharing stuff. No, I don't know. Nuclear scientists do not share this. Biologists do not share. They have a problem sharing data and all of that. And we decided a long time ago to go for replicability, and this has been the basis for this very fast progress. No. Now we are seeing this going a little bit back, and some of these results start to be close, and OpenAI started doing this, and of course you need to make money because things are expensive. No, this is a zero-sum game at the end. But I do value. I think it's a very important takeaway message. No, so thanks. I don't know, Marcio, if you want to say something, because just speak, okay?
Yeah, no, and I think we are in a great momentum for the industry as a whole, because again, we have some great companies working to provide all the best and the latest technologies available, and I think the community will be the one benefiting for all the efforts that we're putting together and available to the ecosystem. So again, it's a great momentum, and I think on behalf of NVIDIA, we're going to continue to thrive in bringing and allowing an easy access to all of our latest technologies so the scientists can put into practice all their knowledge.
Nicolás or Santiago, if you have any.
No, I think that it's interesting we can be competitors, but at the end, we are also trying to help promote an industry, a better industry, a more integrated. So I think we have a responsibility there, definitely, on bringing the tools, bringing that openness. We are all companies. We need to, we make money, but we also need to provide something to the industry. And I think a good part of it's on us. And I think we're trying to provide all the tools. And I would say AMD, probably the structure that has been growing the most is the software part that is working to bring in those tools for all the developers and work with them. So yeah, I agree. It's a great moment.
Thanks. Santiago, if you, as you please, feel free. It's
conversation. No, just to close this is, I think HPC, as I said it, is probably one of the segments that's probably less open. So opening this even further is very important, and for Intel it's critical. It's a critical market segment, and as a data point, Intel has around 15,000 software engineers in a company that's around 100,000 employees. So almost 15% of its workforce is software developers, because we want to make everything open. Interoperability is very critical, and for every segment, including HPC.
Thanks. Awesome. I propose you to move forward because we have a lot of topics to talk about. The next one is another dichotomy between performance and power efficiency or power or energy consumption, as we want to say it. No. So how is the position of your companies? If you can comment us what you are doing around this topic, that is very important. We already just saw in the previous presentation, and this at least in AI is a very hot topic that we have realized that let's say we are saving the world by burning the Amazon. No, so it's a trade-off. I don't know. Let's change let's start with you now, Santiago.
Closer. Okay. I think this is probably one of the most fascinating and controversial topics right now with energy. Of course, in HPC and in AI overall. But there's things that we can do to mitigate this. One is that we can start by the chip design itself. Us companies, we have responsibilities of making the design of the chips to be every time, every new launch to have, let's say, better efficiency. So an example in the case of Intel is just last week we launched our latest Xeon 6 processor, which is by definition and by design much more efficient than the previous generation. So that's one thing, design. The other one is the sources of energy. I think a great example is Brazil. Brazil has 90%, from what I understand, of renewable energy sources. So we can strive to, okay, yes, this machines consume a lot of energy, but what kind of energy do we want to use? That's two. The other one would be cooling. There's a lot of different cooling techniques that can be applied. For the case of Intel, we have here in Latin America, in Guadalajara, in Mexico, our design center, where we do a lot of testing and development of new techniques to cool the chips, not only to cool the chips, but to also so that we require less refrigeration. The other part here of HPC is, yes, the chips consume a lot of energy, but how do we dissipate this? So do we need like huge air conditioning machines? No, maybe we could be more efficient in cooling. So basically, there are things that I think that can be done, and Intel has a commitment to make sure that all of these techniques are applied, so that ultimately the chips consume less energy and are more efficient. And even looking forward, right now we have the CPU's architecture that we have right now, but looking forward, Intel is investing in R&D on much more different designs of chips, such as neuromorphic chips and other things that will consume less energy. By the way, very proudly, we do that here in Latin America, in Guadalajara. The R&D teams that are in Guadalajara are involved in these technologies that will come much later, but there is a big commitment on reducing energy consumption.
Thanks. Thank you. Nicolas?
Well, yes, I would say I would answer that question in two dimensions. The first one is, again, what is our strategy? I would say in the last 5 to 6 years, one of the pillars of our growth, I would say the most successful 5 years from the 55 years that the company has been bringing a new technology, an architecture from scratch, improving the design, improving the packaging, improving the fabrication process, and bringing a new technology can really bring answers to modern needs and modern challenges. And I would say the first one was the need of consolidation. There's one thing that also is happening, that there's no more space. I mean, there's no space in the data centers, there's no in the facility to keep expanding them. So we need to work on assuring we can consolidate, do more in less hardware, or have more computing power in what we deliver. And of course, the energy efficiency flag has been an essential pillar of our growth. In fact, we impose ourselves very aggressive objectives. In 2021, we said that by 2025, we will be doing 30x, or we will be 30 times more energy efficient than our products that we were delivering in 2020. Last time we measured was in 2023. We went already at 15%. So I think we're improving hard. We have many examples in the region. We have been working, and we have with the CMM and the NLHPC cluster, where we've been 4 times more productive in terms of performance and twice energy efficient. So I would say that's one of the pillars, how we do our products, which is part of our strategy. The other one that it's probably longer term, but it's in certain way trying to find alternative to continue scaling this skyrocket demand of workloads, data processing. I mean, it keeps growing, and it's planning to keep growing. And we as a company see AI as an end-to-end strategy. We deliver CPU, NPU, GPU for the data center, for the devices, and for the edge. So in that way, one of the things we expect is those devices, the edge, are already starting to process a lot of AI workloads and needs, and that will take some of the demand from data centers and leave them for more intensive processing. So I would say today we have strong and with good performance notebooks and products that are really able to process a lot of requests. And as we see that, we will see them be more power. So, and not also being power, but also that power not being exclusive or expensive, but also bring that level of power and performance to everyone. So I would say that's another way of scaling, having those devices, having the edge closer to where the data is being collected, really performant, and leaving data center for really more intensive activities.
Thanks. Marcio?
Yeah, it is a great question. It's very common nowadays, the challenge of delivering, high performance and in the meantime consuming less energy. So what NVIDIA has been doing for the industry is on every generation that we launch, there's not only an optimization on the software stack, but there is also a reduced consumption of energy. So for example, the Blackwell generation that we're now starting to deliver to our customer, the Blackwell generation will process 4 times more than the Hopper generation that most of the clusters have right now. And it will consume half of what's being consumed now on Hopper. So meaning that customers will have a lot more hardware, but with a lot less consumption. And we also have announced the Rubin platform that will be available to customers in the beginning of at the Q4 of next year, around November of next year. So just to give you the community our sense of responsibility and continue to improve the processing and reducing the energy cost, okay? So we are seeing a lot of movements coming to Brazil, coming to Paraguay, where there is an abundance of clean energy, especially hydric energy. So there's a lot of water in our region and a lot of data centers, not only from Brazil and from Europe, are now moving to the southern part of the hemisphere, because again, there's a lot of clean energy that we are able to use that to empower all the the large data centers that we have in the world. So this is our commitment, and that has always been, even prior to this topic become so popular that it is nowadays. This is our goal, to continue to deliver 4x, 8x performance and consuming less energy, because there's a combination of all the optimization of the software and of course the design of the chips, the architecture of the GPUs that we work really closely with all the OEMs, so we can bring then the latest and the greatest performance without affecting too much of the issues with energy supply.
Thanks. Thank you very much. I mean, this is it's true that, let's say, greenhouse effect is related to energy consumption, but also energy consumption has a direct impact on the cost of operation. No? So dealing with this is actually dealing with both of the topics. I think it's very interesting, and ultimately the solution, I don't know how you see it, but it's a combination. It's not a single action, but the whole stack has to change. Even how we work, how we optimize the models. That instead of using a lot of brute force, try to use some intelligence in the search for hyperparameters, for example, or something like that. That's essential. It's very interesting. But talking about this, the opportunity of having well-placed computing centers and all of that, this takes me to the other dichotomies of either using the cloud or going on premise. No, there is a tension here because, well, using the cloud in theory should be more efficient, less has a linear way of working. No, but then we have the reality that, for example, if today we want to use Google and have an A100, they are not available. No, so people might decide to actually own the iron at home and have because you need to be certain to operate. How do you see this situation? I think I am talking to the right people here. As users, we are concerned on this. I call this the end of capitalism. You have $20,000 on Google and you cannot pay for an 800. So it's like wanting to buy a Rolex and not be able to. I don't know. Let's change the order. Marcio, how do you see this on-premise versus cloud dichotomy?
It is also a good debate. For us, what matters is what is the customer workload? What is the customer is trying to solve, okay? So both on-premise and on the cloud are great, but we are more concerned in what are they trying to solve. And again, not every customer needs to start with a high-end GPU, okay? Because they may not be using the right platforms that are fully optimized to take advantage of our GPUs. So again, I'm glad to hear that you're saying they want to rent a A100, but thank you for that. But again, we do have a lot of GPUs, a lot of different tastes of GPUs that were designed to meet a specific workloads, okay? And what we're seeing now is there are some level of, there's level of customers with a maturity that can make them think whether they should still be using the cloud or starting to have an on-premise infrastructure. Whenever we're involved, we have that journey with the customer to make sure that he takes full advantage of their return on their investment, okay? So nowadays, we're experiencing the large cloud service providers. They are indeed one of our main customers, but we're now seeing large corporations starting to think in building their own data center, and they are getting some good returns on their investment. Although a lot of news that customers are not yet seeing returns on their investment, they are, of course. There's a lot of, let's say, misleading information in regards of how big your infrastructure needs to be. Okay, we know it's going to have to be big eventually, but at that point, most of the customers, including Latin America, they don't need to start too big, because again, once they open up the newspaper and they see that companies like OpenAI, to train ChatGPT, they have to have 10,000 plus GPUs, but that's only for them. Now they use over 30,000 GPUs. So, but for majority of our customers in Latin America, you don't need that many GPUs to begin with. What you need is the right GPU and mainly the right software stack to take advantage of your investment, okay?
Thanks, thank you very much. Nicolas, you're...
Well, yeah, just to add something to that, we've seen in the last few years, generally speaking, customers really moving very fast to the cloud. It was like a reaction on trying to scale their services, but at the end, when they start looking at their cost and how efficient those services were in the cloud versus doing their own, we are seeing them coming back or trying to work on this hybrid model where there are some things that are important in the cloud, some are important or useful on-prem. Again, going to HPC, I think that when working with some of the organizations, universities, main big companies, I would say the on-prem brings a lot of good results in terms of deploying their own infrastructure, the velocity and the scalability, the volume of data they need to process, the communication, the uploading that information. And again, in some other that are the startups or the one that really need to scale quickly, the cloud brings their own benefits. For us, again, as Marcio was saying, we want to be the trusted advisors, right? We have the hyperscalers are great customer for us. They have been buying everything for us, and they have a variety of platform there for every different service. But at the end, what we also need to understand is what's the workload, what's the objectives, what are they looking for, how intensive that information is going to be. So I would say it's a debate where there's a lot also hidden costs that have been appearing. The egress cost is also important to have there. So it's not an easy, but it will depend on many factors. So again, I would say our position here is to really be advisors, making sure what are the objectives they need, and have the right view and propose the right model for each of them. So I would say this debate is going to continue probably as the cloud become more efficient, they become more powerful, but at the same time, we provide it for on-prem product that can bring more consolidation and with the energy efficiency that we have been talking.
Thanks. Santiago?
For this, clearly a big debate. As Intel, we see that ultimately what the key decision factor here should be driven by depending on what you want to accomplish, on what's your objective. And I think we think for that there's 4 different criteria that you should apply. Number 1 is definitely budget, cost. What kind of budget do you have? The other one is considerations on scalability, flexibility, what kind of what's important there. The other one is latency, bandwidth. That's the third consideration, and lastly, it's the data, security. What's the usage of the data? So depending on those 4 criteria and how you apply them, you should either go for on-premise or cloud. And I think in the case of HPC, depending on what you actually want to accomplish, you could go either way. So let's analyze the 4. So cost or budget. Setting up one of the systems is extremely expensive, costly. So not everyone has the budget. So maybe there's a cloud option, or if there is a budget and probably, I don't know, there's a government involved, maybe it could be on-premise. On the other ones, on flexibility, scalability. If flexibility and scalability is critical, depending on what you want to accomplish, you could go either to the cloud or on-premise. For example, or on scalability, if you really are looking ahead and say, okay, my requirements are going to be very massive, probably you should invest in local infrastructure and just have that over time to be utilized. Or if you are not so sure, maybe you should start in the cloud and then go more flexible. The other one is latency, bandwidth. Depending on the application, it's probably more critical and sensitive to have the hardware on-prem. I think yesterday we were talking about a very good success story that we have here in Latin America, in Argentina, with Intel and the National Service for Climate Service in Argentina. It's an HPC with Intel inside that probably there you need the latency is critical, so you need probably the hardware there. And when you evaluate all of these parameters, including the data sovereignty issues, because if there's, I don't know, a highly sensitive application, maybe you don't want that data to be on the cloud. So maybe you need it on-prem, or if not that sensitive, you could go to the cloud. So I think what I'm trying to get is, depending on ultimately the objective and the application, applying these 4 criteria, you could go either way, and have that option and flexibility is always good.
Thanks. I mean, this is, for at least from my point of view as user, there is always this tension of control versus facility of operation. It's the same as having a car or a taxi, no? That the cloud is a taxi. You can always call it, but maybe it will not come, and so you tend to have a car that then the car is parked 90% of the time, as my car is now parked all day, you know? So, but I don't know if we are going to ever solve this. I remember, actually was here on CMM, there was a presentation from a Japanese professor that is one of the members of the board of CMM from Toyota, I think he was, that he was explaining this idea for cloud, for autonomous cars, to share the computing power across cars. So you are driving, and the other cars that are parked are doing part of your computation as you drive, no? Because there was too much compute for a single car to take care of all of this. And actually, I don't know if it will ever be possible, but it will be awesome to have this hybrid cloud on-premise that I can put my on-premise to work while I am not using it. I don't know, it's maybe a fantasy, but maybe it's a business model. You can. Yeah. Please erase what I said. Thanks. So then, you know, the year is coming to an end, and Christmas is coming. And I was thinking, now that we understand all of this, what can we ask for Santa Claus, or let's say our governments that are similar to, now that we understand, or let's say have debated all of this, what are the key government policies that you think should be implemented by those that, let's say, can change things in Latin America in order to make an effective use of this HPC and AI and, you know, in this broad domain? If you want, let's do the opposite round and start with you, Santiago.
Okay. Thank you. So I think this is a critical moment in the world, and of course in Latin America, to really define what we want to do with these wonderful technologies, and that ultimately leads to have this sometimes difficult conversations. Okay, on what's the government role and what should we do, or the academia there. And I think there's some things that are already happening. In some countries, there's already talks about okay, what kind of regulatory considerations do we need to have? Actually, here in Chile, there's right now a big debate there on, okay, what can be done to probably more on the regulation side, but that's one thing that's being discussed. In other countries, there's more talks about, okay, how do we accelerate AI, and what kind of things do we need to do as a government? So we're looking like countries like Brazil, like Colombia are already having these discussions. Okay, how do we accelerate, and having national policies for AI? That's another way to see it. So those are two considerations. The other big movement that we're seeing that as Intel we're very pleased to see that there's already talks about a Latin America Council for AI and collaboration, because as a region, United, we're a very powerful region, and if there's some sort of council that can help accelerate it, that's great. By the way, emulating this or collaborating as collaboration efforts, such as what you guys do with SCALAC, that collaboration intra-countries and what's being done is something that can help definitely accelerate AI. And I think ultimately all of this debate is we'll see how that goes, and that Santa Claus letter, how that ultimately happens, because this debate is necessary. But I just want to say that as long as it does not interfere with innovation, because sometimes, unfortunately, when these debates happen, either the government gets involved in a different approach, and if innovation is hindered, that's what we need. We need to ensure that as an industry we have our watching eye there, because it's a critical moment. These technologies can be transformative for regions like Latin America. Let's make sure that whatever that Santa Claus letter ultimately brings as gifts, it leads to more innovation.
Thanks. Nicolas?
Well, taking that idea of my letter to Santa Claus and taking what you said, is I would say government needs to work on the framework, definitely. But one of the important things to not stop or make innovation slower is making sure they bring two other audiences. The first one is the companies. Private companies are the ones that really bring the solutions, trying to invest in new technology, trying to bring them to the table, make sure what they have. Again, we are companies, we have a commercial, we need to make money, but also we bring all the technology there. So that's an important part of the conversation. And the third one is academia, is the academy environment. I think that by definition, if the academy is looking for a commonwealth, is trying to put those innovations in a way that brings benefit to the society, to improve the scientific innovation, brings a lot of new things. So I would say that's, if we have those three people, those three audiences sitting the same table, that would be a great start. And I was reading for the Indice Latin America of AI, and again, Chile, Brazil, Uruguay are probably one of the countries that has a higher score. And in certain way, I'm seeing, because that is, again, we have a lot of things to do, but that is moving the right way. And also, again, there's a lot of things we cannot work or think of improving this activity without the right infrastructure, or promoting the right infrastructure, connectivity, for example, education. I was reading, Latin America has a long record, a track record of service, people trying to provide services, engineering, but we don't have enough. So not only putting that level of education in the university, but also starting to incorporate some of these AI tools and notions from schools. It will eventually be so big that it's like a cell phone today or internet. So I would say I was reading the other way, or usually they ask, is AI going to replace people? I would say, and I believe not, but it's probably going to replace people without that won't take the AI tools or won't incorporate AI in work in some other things. So we need to have that, be prepared for that. And again, I would say promoting the investments in having more data centers, in more companies investing in the countries. So there's a lot of things we can do. But the first thing, we start having these three parts in the right place, providing their knowledge, giving their feedback, and I would say that would be a great start.
Thanks. Marcio?
Yeah, about 8 years ago, NVIDIA has launched a program called AI Nations, okay? And about a month ago, we were able to sign an agreement with Chile. So we're very pleased and honored to be closer to the Chilean government and assess and help them to promote AI among all the top universities and national labs. In Latin America, we have this agreement signed with 6 countries already. Brazil, of course, I'm based in Brazil, it's one of them. And we are expanding. There's about 8 more countries in Latin America that are now working closely with us, and we'll be soon announcing their names as well. But worldwide, we've been able to help governments to design and to review their AI regulations. And they all have the same concern, how to keep their data inside their boundaries. So the AI sovereignty topic is very crucial for any government and of course, any institution. So again, we are having that pleasure due to our position and expertise in the market to sign this agreement and put our commitment to elevate the knowledge in this country. So Chile, like I said, was the last one or the most recent one in Latin America. And again, the government, as was said before, their role is to really define what are the rules and regulations, but as long they're not inhibit the technology, the how can I say, the innovation mode, because again, it's boundless. And what we're seeing, countries, for example, like Mexico, are hosting a lot of multinational companies that are moving to Mexico. We're pleased to work with a lot of software companies that are coming from Eastern Europe, coming from China and being installed in Mexico. And those guys are eager to bring innovation to the country. And of course, they will be servicing the entire world, So again, there's a lot of potentials in Chile. And it's just a coincidence that this year, Carla is being happening in Chile. But the Chilean government is, I would say, one of the most active one. Again, it's good that because it's a small country. And as I tell everyone, it's not about being big or small. It's about being agile. It's about being, open to innovations and using the technology on their benefit to continue to emerge, continue to be ahead of any other countries or the competition.
Thanks. Thank you very much. By the way, it seems that Christmas arrived earlier in Chile this year. So, você está mute. Márcio, não escutamos você. Não. Aconteceu. We are not listening to you. Okay.
It's like ONU when they close. It's time they turn off the
Is there an AMD or Intel chip in this system? No, so it's this. I mean, this is going to be like the eternal discussion. I think, in particular in Latin America, that I think in general for us is we tend to hesitate all the time. It's like everybody's waiting to jump in the swimming pool. No one wants to be the first. No one wants to be the last. We were talking about this the other day, and so it's very. But then the worst thing is not jumping, no? So, and Nicolas, you were mentioning something, and also Santiago, that I find, like, what is the role of these, let's say, of the policymakers, no? Because as a, let's say, AI scientist, I feel sometimes like there is a tendency to fall for the easy stuff, that is to regulate, you know, because this is really dangerous, and you know, you can make a photo of a dog with two heads, and this is really, really dangerous, so we better stop it. No? I personally found, I don't know, irrational, to use a polite word, this proposal of stopping AI research for 6 months. I mean, I will love it. I will go on vacation for 6 months, but in general, it doesn't make sense, because the people that were about to stop were actually capable of solving the problems, while the people that were planning, let's say, bad uses of AI will never stop, because they are bad guys. No? I find that, and for that, I think in my letter, it's like, please ask not only lawyers and all of this, but also technical people, because for many of these problems, actually, there are a lot of people working on solving them. No? And I don't know, ChatGPT is a very good example. The first GPTs were a disaster when they generated text. They got to work. Maybe the way they did it was not like the brightest way, because it involved a lot of people doing, again, more human work, because at the end of all of this, it's a lot of human work. But now it's, let's say, safe. No? Maybe it's even boring. No? One of the ways to detect ChatGPT text is it tends to be boring, no? Because it's like too politically correct all the time. No? But again, there is this, let's say, the over-regulation, I think, can actually drown innovation. This is very important, never to stop it. And also, I think that in the same way, they build roads and highways, and they also be there doing the strategic investment, no? What they want to develop, and in that sense is very important. I think that in Latin America, more or less, is a common understanding, but it's still, I feel this thing of, we know that we need to do it, but okay, you need to, commit. No? I don't know if you have any more comments we're about to, or if there is any question from the audience. Yes, do you have another mic? Okay. Which chair? Here.
Hi. So this is not an easy question, but how are your companies dealing with the possible risk of a war in Taiwan?
I am buying a sailboat. I don't know. Do you have
Can you hear me or no?
Yes.
Yes.
Go ahead, Marcel.
I mean, we, as NVIDIA, we've been navigating on adversity from the beginning. Taiwan for us, it's key, it's crucial. TSMC delivers the best chip that we can have. And again, we continue to work with the commitment to design and bring to the world the latest and greatest GPUs. So again, it is a topic that's going to be living forever. There's a lot of geopolitical topics right now, but again, we are a tech company, and we are positive that whatever happens, we'll be able to go around and continue to produce the latest and greatest technology.
Thanks.
I'm not going to comment about the conflicts or Taiwan, but what I can tell about what Intel is working on is we want to ensure that the world has a resilient supply chain for semiconductors. So we are absolutely committed on that. We've been investing thousands of millions of dollars on building new capacity for the world so that we ensure that if whatever happens anywhere, there is a stable supply chain of semiconductors flowing. I think we saw in the pandemic, I think it was for everyone, it was very visible that what could happen, the world could stop without semiconductors. So Intel is absolutely committed on that, and that's a key part of our strategy.
Well, again, for AMD, TSMC is our main provider. So again, I would say also our CEO, Lisa Su, is part of the group that assessed and helps Joe Biden and the US government on alternative. They're part of the group that is trying to bring solutions or alternatives. I think they're working hard there. And again, I would say it's a key part of what we are trying to protect right now. I'm sure this will it's so important for the whole world that it will eventually continue one way or the other. But we're working with all the opportunities, all the options, and again, I would say we need to see how things are going. But it's at a high level, working very hard on that.
Well, thank you. We ran out of time, and it has been a wonderful 1 hour conversation. Yeah. Awesome. I wanted to thank you all for being involved with this, and thanks Ines for the invitation to take part, and thank you all. Thanks. Ciao, Marcio.
Gracias. very welcome Professor Antônio Tadeu from LNCC. No? Yeah, and he's going to talk about the impact of job scheduling policies changes on user behavior and system response, the case of the Santos Dumont supercomputer in Brazil. Professor, 15 minutes.
Thank you. All right, just check. Yeah, thank you. Thank you for the presentation, Andre. So this is actually a work that is part of a larger project that aims at helping users and the projects that make use of the Santos Dumont supercomputing facility at LNCC. So to give a short introduction, the problem that motivates this work is the high heterogeneity of jobs in national lab supercomputers, and also the complex setup of job schedulers that we have nowadays, involving features such as backfilling, multi-factor prioritization, and the combination of these two issues and also the regular review of the job scheduling policies that are related with the fact that the users come and go and projects begin and end in this infrastructure. So we are always in need of reviewing the job scheduling policies that we have in our supercomputing center. There are some a bunch of related work that deals with that by doing some workload analysis, but as far as we know, there is no other work that analyzed the effect of those changes in policy, in job scheduling policy in this system. So this was the main idea of this preliminary work that we have some follow-ups in other pieces of work as well. So the main objectives of this work are twofold. The first one, from a methodological point of view, is to characterize the user behavior and the system response when both the system and the user are faced with policy changes. And we do this characterization by an exploratory analysis of the distribution shift of the job geometry, the inter-arrival time of jobs, and the waiting time of jobs in queue. For those who don't know this geometry terminology, it's basically the product between the amount of cores that a job requests and the time that this job asked for the job scheduling system, or the actual time spent by the job. And the second part is a practical one, to apply this methodology in the Santos Dumont using workload traces from mid-2017 to mid-19 with a policy change that happened just in the middle of this period, which was aimed at reducing the queue waiting time. We did some preliminary evaluation of this change in the policies. We arrived at the conclusion that by looking at the statistics that the 95th percentile of the queue waiting time has been reduced, and this was nice. So we had a good idea of the jobs experiencing smaller queue, shorter queue waiting time. But we'd like to analyze the different effect of this change and this reduction in different sorts of projects, different sorts of jobs. So to talk about the methodology, just let me explain a bit about how the Santos Dumont supercomputer operates. So projects are awarded after being evaluated by a committee, and the projects that are approved, they open accounts that are related with a user group, and each of these projects, each of these user groups are usually within a specific knowledge domain. So we have projects related with physics, chemistry, or material science, climatology, and so on and so forth. Well, the machine has two different partition sets. Because of the two different technologies that comprise the system, I will just take a look at the older one, basically because during this period you only had a single change in policy, and also there wasn't an intervention with other projects that were out of our control, because the second technology involved projects also from Petrobras, which was the main funding partner in that project. So we evaluated the changes in this first system. Before the changes in policy that we made in mid-2018, we had a bunch of queues with different parameters, and after the change in this configuration, we created the new queues basically for small jobs and changed the minimum amount of cores that the other queues would allow. And with this change, we could have a better control on the queue waiting time of the jobs. But we'd like to, as I said before, we'd like to understand better this change in the response system and the relation between the change in the response system with the change in the user behavior. Did the change in the policy in the scheduling policy change the user behavior, or these changes were only a consequence of the new policy, implying a reduction in the queue waiting time? So to do that, we took the amount, we took 57 projects out of the 130 projects that run at that time at Santos Dumont. And why this number? Because these 57 projects were present in both the period before the changes in the policy, the BC period, and after the changes in policies, the AC period. And this amount of projects amount to 85% of the total CPU time consumed, so quite representative of the usage of the system. So to make this analysis, we made an interesting, a simple experiment. In fact, we took the original period and split in two parts. The first part, which comprises the period before the change in the policy, and the second period, the period after the change in the policy. And besides this scenario that we call the CP, the change in policy, we also created two other scenarios, NCP1 and NCP2 periods, which correspond to periods where we didn't have changes in policy. But we also split this time in two parts, the first period and the second period. And the main idea here was to observe whether changes in user behavior in terms of inter-arrival time of jobs, the geometry of the jobs, and correspondingly the system response, the queue waiting time, we'd like to check whether these changes happened here but didn't happen here. And to do that, we applied the two-sample Kolmogorov-Smirnov statistical tests, both comparing if the distributions were the same or whether they were consistently larger for the period after the change or smaller after the period of the change. And the idea was to compare these distributions in the inter-arrival time and the geometry, and afterwards also in the queue waiting time for these three different scenarios. And what we observed was that, in fact, the user behavior changes irrespective of having changes in policy or not. Well, why that? Well, there are many things involved. The phase of the project where it currently is, the influence of external variables such as conference deadlines, vacations, carnival, whatever. And so it was very difficult to apply this strategy to compare these different scenarios. The scenario that would like to validate the change in the user behavior in comparison to the other ones that we guessed we wouldn't find a change in user behavior. You were wrong. So we couldn't assess this, at least in general. For the queue waiting time, we were more confident because we had the results, the previous results from this work that have shown that the 95 percentile of the queue waiting time of the jobs after the change in the policy was much smaller, 3 times smaller than before the change in the behavior. But even so, we couldn't validate the hypothesis that we thought would be validated. And this was weird for us, so we tried to make a zoom in the data related with these distributions, and by taking a look at the CDF of the different quartiles of this distribution, we observed an interesting effect. The jobs that, if you can see here, the blue line that corresponds to the before change period, and the dashed line, the after change period, the blue line goes up to this point, which corresponds to a 5,360 seconds threshold on the Q waiting time, where the curves they change positions. So basically, what how can we read that? Jobs that had a small Q waiting time, after the change in the policy, they started experimenting higher Q waiting times. But the jobs that previously had long Q waiting times, that they had a reduction in the Q waiting time. And the net effect of these changes was that the overall Q waiting time of the system was better, because the small jobs, the difference was not so big for them, but for the big jobs, the jobs that usually experience larger waiting times, they experienced a large improvement in their quality of experience, in fact. So, okay, so we have this difference in short and long jobs. So what we did two cohorts, the cohort of jobs with short Q waiting time and jobs with long Q waiting time. And when we did that and reapplied the technique, the two-sample QS test, we had a confirmation of the hypothesis that we'd like, but again, we couldn't connect that confirmation of the null hypothesis for Q waiting time with the user behavior. But when we look at the cohort for jobs with long Q waiting time, yes, we had the confirmation, the expected confirmation of the null hypothesis for Q waiting time being smaller for the jobs with long Q waiting time, and we observed the connection with the change in user behavior. So the sperma coefficient increased a lot here, but when we plot this, it's still a mess. So actually, the preliminary conclusion that we had with this first evaluation, we weren't happy. We didn't arrive at the result that we thought we would arrive. And the reason for that, we believed, was that the analyses were too coarse-grained. We were looking at the jobs in general. We weren't looking at the types of jobs, the types of applications that explore the machine. So we did another experiment that would try to put together the three measures that we were interested in evaluating: the user behavior measures, inter-arrival time of jobs, and the job geometry, and the system response, the Q waiting time. And to put these guys together in a simple visualization, we devised a simple measure, which is the AC to BC ratio, which is basically the median of the measure in the AC period divided by the median of the measure in the BC period. So if the AC to BC ratio is less than 1, then it corresponds to a decrease in the median of the metric. Otherwise, an increase in the metric. So we measured this measure for these three variables and try to plot everything together and using the two cohorts that we have created. So for the jobs with short Q waiting time, what we could see, well, what we are plotting here. So in the axis we have the AC to BC ratio for inter-arrival time. In the y-axis, the AC to BC ratio for the geometry, and the triangles and the rectangles, they represent the AC to BC ratio as related with the Q waiting time. If it is a triangle, it's a ratio less than 1, which means the queue waiting time improved for that specific project. Now we are looking at projects. Each rectangle and each triangle corresponds to the median of these specific measures for a specific project. And if you look at the jobs with short queue waiting time, there isn't much really to be seen here. But when we look at the jobs with long queue waiting time, we can clearly observe a concentration of projects that improved that queue waiting time because they reduced their the geometry of the jobs. They started submitting jobs either with a smaller time, expected time to complete, or reduce their amount of course, or both. So the preliminary results that we have with this project is that scheduling adjustments, they have effects that very difficult to evaluate, and in line with some of the literature, we can observe that looking at the affinity-based interpretation, in our case, looking at jobs that are from the same, let's say, family, the same project or the same knowledge area, helps in understanding these behavior changes. So, because we observe that irrespective of the changes in the user behavior happening on during changes in policy or not, because their behavior is dynamic, it enforces the need for adaptive data-driven scheduling algorithms to meet these evolving demands of the HPC intensive R&D in supercomputing centers, which is in line with other pieces of work that have exploring this. And for future work, we also would like to evaluate the system response not only in terms of the quality of experience of the user, queue waiting time, but also from the point of view of system utilization, and explore other factors that we didn't have for the measures that we made between 2017 and 2018, when we could allocate the whole nodes in the supercomputer, and now we have nodes that are much more dense in terms of number of cores, and because of that we need to share the nodes between different jobs in a single time frame. So these are other things that we must take into account, aside many other things like taking a look at also the memory consumption to evaluate whether putting different jobs from different projects with different demands could share the resources of shared nodes without compromising too much the performance of either jobs. So this is the main idea of this work, and I hope we have time for some questions.
Okay.
15 minutes.
Okay, questions?
Yeah, there are more questions?
Sergio.
Oh, no more questions. Okay. I have a couple. Thank you for your presentation. It's very interesting working with the users and the methodology used. The first one is, did you think about creating some kind of feedback from the user more than the waiting time? You know, which is the feeling of the person using the system before the changes. Not only the queue time, what is the relation with the system of
the subjective.
Yeah, what is the feeling of the user affected by the change?
Yeah, I don't have objective measures for this subjective quality of experience. What we have at LNCC are emails.
Yeah, the amount of complaints of emails, yeah, this is not working now.
Yeah.
I am affected. I'm gonna kill you.
No, in fact, many users liked a lot the changes and the response that the system gave to them. The complaints still continue because, well, in the 95% queue, the jobs would wait 54 hours to start running, and they started after the change in the period. The worst case was 19 hours for the 95% use, so it was quite an improvement. And as I said, mostly for those that were in more desperate need for a faster response from the system, which was the larger jobs.
Okay. And I think I missed.
I ran a lot, sorry.
Yeah, yeah, but what is the proportion between quality of service project where the amount or the number of submissions you have to fulfill in terms of the project, and some which are out of which are a single user sending, or you have different quality of service for projects, priority projects or less? Do you have some kind of differentiation in the submission?
We do have two different forms of differentiation in the project. The first one is based on experience, so and the productivity. So basically it works like that. When we first arrived as a user at Santos Dumont, and you have a project that is approved, you receive a standard.
All the users have a project approved to access the machine. You can be, there are users inside the institution which use the machine without having a project approved?
No.
Like free riders, they have, all of them are assigned to a project and assign a number of hours in the machine.
Yes,
okay.
Yes. So the standard projects, they receive a smaller amount of CPU hours, and they have less priority and access to, you don't have access to some queues that the premium projects, which are projects that only a user that has already another project approved, run with results, they have access to. And also there is another thing that is the fact that we give some credit in terms of CPU hours to each project, and different from other centers, when the project uses all the amount of CPU hours that it has right to use, we don't block their submissions. We reduce the priority of their jobs. Okay. So everybody can keep on using, but with a smaller priority. Okay. And the users are informed of that. So yeah, they complained because they had a reduction in priority, but he didn't made a nice estimate of the amount of CPU hours that he would need. Basically that.
Okay, and the relation between this, the last one, yes, and the relation within in the data sets, they are the same proportion of both kind of users and submissions in both data sets after and before the changes?
Yes.
They keep in the same.
Yes, actually I have this information because I ran so.
Yeah, you run a little.
It's
here you put the number of shops, but the classification of each shop in priority, not priority.
No, I didn't collect
and are in your feeling they are the same? Did you check it?
No, I didn't check that.
How to do that?
Thank you. Sergio? Okay.
Last question, please.
Okay. Okay, thank you. Nice talk. This is a simple question, not like Mr. Big Questions over there. Yeah, several, yeah. No, in the main findings you are referring to the affinity, but I think you mean software affinity. I was wondering if you explore some about hardware affinity.
No. Actually, when I said that the groups, they usually refer to specific knowledge domains. Usually this leads to different sorts of software that the groups use. So let's say material science, you have some.
So they are not categorized by the type of hardware they require?
No.
Okay. Thank you.
Yeah?
Let's thank the speaker again, please.
Thank you.
¿Necesitas móvil o prefieres fijo? ¿Necesitas móvil o prefieres fijo? Okay. Our next speaker is Josef Ruzicka from the Technological of Costa Rica. Yeah. Okay. And he's going to talk about the study of performance portability in plasma physics simulations. You have 50 minutes.
You have the pointer. Thank you very much. It's a real pleasure being here. This presentation is divided in 5 stages, and I'm going to start by talking a little bit of our motivation and why this work was important for us. So as the environmental and energetic needs of our planet call for a turning away from fossil fuels, there's been a growing interest in research and society for clean and renewable energy sources like nuclear fusion, for example. Here we can observe 2 stellar radars, the Wendelstein 7X and the SCR-1, which are plasma confinement devices. These are helically symmetric toroidal tubes surrounded by solenoidal coils that generate a magnetic field that it can be used to influence charged particles, or say, for example, atoms of hydrogen that can then fuse into helium, and this can be used to generate energy. But the actual assembly and design and testing of these machines is quite complex and expensive, which is why it is crucial to rely on computational simulations. Now, the simulations are no free lunch either, right? They are complex, and you often rely on vast amounts of calculations over lots of data. So this is usually done on high-performance computing systems. This typically follows the message passing paradigm, where we have some sort of message passing standard like MPI for distributed memory parallelism, and then we have another model X that handles intranode parallelism. So there's been a widening diversity in computer architectures. So this X model can be tons of options depending on our architecture, and this also has another effect, which is that different memory access patterns and different data layouts suit better different architectures. So take, for instance, this image where we have some GPU memory access patterns, and we have lines of contiguous memory represented as the rows there. And we can see these lines, if we need to access them, they need to be completely loaded, even if we are only going to be using part of these lines. So if we use a coalesced access pattern where each thread would access some portion of these lines, we would only need one load operation. Whereas if we use the blocked access pattern on the right-hand side, where each thread accesses a different line of memory, we would need one load operation for each of these lines. So this is computationally expensive, and this decision can have a big impact on the performance of our applications. So for this reason, it is desirable to be able to program these simulations on a performance portable manner. And what we mean here is that we can reuse the same source code on a wide variety of architectures without sacrificing much of our performance. There's been a number of performance programming models and frameworks designed for this, and so the idea is that they are able to abstract these different parts of the code, like the memory layouts, regardless of if we are using the CUDA space, the heap space, or if we want to use CPUs, or whatever we decide or we have available in our architectures. So previously, as part of the design of the SCR-1 stellator we saw earlier, our team developed the BS Ultra, or Biot-Savart solver, for computing and tracing magnetic field lines. And this was originally designed to run on CPUs, and the data layouts were the ones we have on the left-hand side here. So we had basically some structs of arrays where we have 3 arrays representing the coordinates or spatial positions of each of our structures. This work was then continued to port it to GPU, and for easier data transferring between devices, there was a decision made to convert all these data structures into one-dimensional arrays where each 3 spaces have the information of each single particle or coil and every data structure represented. This change helped us to obtain a speed up of over 5 times, which at a first glance sounds pretty great, but there's a catch. When we ran the new code variant on CPUs, we had a 6.7 times slowdown relative to the original results we had on the original version of the code. So this led us to notice that there was something off, and we decided to develop a performance portable version of this code. To get a little bit into the details of what this simulation does, this is basically a field line tracer that was developed on OpenMP originally. And we basically represent the coils as a sequence of straight lines or filamentary segments, which can be used to calculate the magnetic field at every point in space. And this magnetic field can be used to approximate the trajectories of the particles, and we did this with a Runge-Kutta of fourth order algorithm. In addition to this simulation to explore other representative HPC plasma physics simulations, we also decided to adapt particle in cell, and for this we decided to use the parallel research kernels PIC, which was also developed in OpenMP. And this simulation basically represents a two-dimensional grid with charges on its mesh points, which are the green dots here. And in each iteration, these charges exert forces on the particles of the four surrounding cells. And in return, each particle also affects the charge of the mesh points of the four neighboring mesh points of each particle, right? So this simulation also offers different initialization patterns for particles to induce some load balancing scenarios, but we are focusing on the X intranode parallelism models, so we should expect that different load balancing scenarios shouldn't affect our results. Now, to measure how performance portable our new implementation was going to be, we decided to adopt Pennycook's performance portability metric, which considers a set of platforms, which are the devices we're going to be running our code in, an application that solves a problem. So we have our code variants that solve either the field line tracing or the particle in cell. And we also have the efficiencies of these applications. Now, there's a number of ways on which we can measure this efficiency, but we decided to use application efficiency, which basically means that for each execution, we define our efficiency as a fraction of the best observed the performance obtained as a fraction of the best observed performance on each platform. Now, to develop our new code variants, we decided to use COCOS because in the literature it had proved to obtain some of the best performance portability results on some of the widest varieties of hardware. And COCOS offers something which is very valuable, which is the COCOS views, which are an abstraction of the data structures we want to use, which basically lets us define an execution and a memory space during compile time. So I can program my code, my data structures, store them in a COCOS view, and during compilation I can hint the compiler if I want to use the CPU, a specific CPU, or a specific GPU, and if I want to use the managed memory alternatives like CUDA, UVM space, or heap managed space. So COCOS gives us this, and we decided to do a full porting of PS Ultra, changing every one-dimensional array into a COCOS view. And then in the PIC, we had the particles represented as structs with coordinates, velocities, accelerations, charges. So we decided to keep these structs and store them in COCOS views of these structs. So to run our code variants and test them, we used the Cortés supercomputer in Costa Rica, the Raven supercomputer in the Max Planck Institute in Germany, the AMD Accelerator Cloud, and an NVIDIA Grace Hopper machine. So we had GPUs from NVIDIA and AMD, and CPUs from Intel, AMD, and NVIDIA. So for our results, we have on the left-hand side our CPU results, and on the green line here, we can observe the original time durations of the BS Ultra execution. And this green line is the CPU-only version that was optimized for only CPU. And we can observe that our Cocos version on this line is about 2.5 times slower, which is way less drastic than the 6.7 times that we had previously obtained with when we did the porting. On the right-hand side, we can see that on the older V100 and A100 GPUs on these lines, our Cocos code variant was not as good as the OpenMP version, but this difference was then settled on the MI210 GPU, and on the newer MI300 and H100 GPUs, this was the other way around, where we have Cocos performing better than the OpenMP variants. We also decided to test how these program code variants would scale. So we used up to 16 GPUs, and we did two experiments. Our strong scaling experiment on the left-hand side basically means that we have a particle count or a problem size, and this is evenly distributed between the GPU counts we have. So we should expect that double the GPUs would achieve double the speed up. This is represented in the ideal dotted line here. And we can see that in our largest problem size, we were close to this, but the reason why it is not ideal is because these problem sizes were not large enough to saturate all the GPUs we had at the moment. And on the right-hand side, we have the weak scaling experiment, which means that our problem size scales with the amount of GPUs in use. So if we have 16 GPUs, each one of those has this amount of particles, for each problem size. And as there are no deviations in any configuration, we have ideal weak scaling here for both our Cocos code variant and the previous OpenMP code variants. So when we measure the application efficiencies of these results, we can observe here that when Cocos was outperforming OpenMP, the application efficiencies obtained by OpenMP were not were quite low. We have these 61, 57, and 37% of application efficiencies. And using these application efficiencies on the Pennycook's equation we saw earlier, we obtain these results. Now, on this platform set that only takes into account the GPUs used, we observe that the OpenMP baseline code variants only achieved 78% of performance portability. And when we include the CPU we used for this experiment, it goes down to 66%, while Cocos never fell below 96%. Now, on the particle in cell results, we have the CPU results on the left, and we have Cocos with the crosshatch pattern, and we can observe that on the CPU, the results were better for Cocos on both CPUs tested. And then on the right-hand side, we have the GPUs, and we can see that for the V100, Cocos was better, but with the A100, it was the other way around, but the difference here are very slight. So again, when we calculate the application efficiencies of these results, we again see that for some devices, OpenMP got quite low application efficiencies, like this 64% or this 72% here. Using this on the performance portability metric, we again get some low results for OpenMP with 67% on the CPUs and 80% on all the devices considered. So basically, we obtained some very performance portable versions of our code with Cocos, with both simulations never falling below 96%. And we also observed that on the newest architectures, Cocos did seem to obtain some of the best results. And it's important to keep in mind that this kind of study is quite important to observe how different problems behave with different hardware and different programming models. But many times when we have to develop a big code base, we won't have the chance to to develop multiple code variants, and so we won't be able to measure the application efficiencies of these code variants. So for this reason, we consider that future performance portability studies should focus on performance modeling. And of course, there's some further optimizations and explorations that we can do on our code variants to obtain some more detailed results. But this is what I was going to show today, so thank you very much.
Start with the question sessions. Professor Moore.
Thank you for this great talk and great presentation. I just have a few more detailed questions, understanding everything correctly what I saw. When you said you're using OpenMP on the GPUs, I guess you're using the target construct to report that, because like in our experience, this is kind of relative new, and the runtime synthesis are quite new, and they're even sometimes buggy. So it's not surprising that the OpenMP results on GPUs are lower or something.
Mm-hmm.
So this was more a comment, not a question, sorry. The second one was more, I guess you have it in the paper, but you didn't say anything about how the compilation, like how do you make sure that on the different platforms you kind of use the same level of compiler optimization codes and stuff like that? Because I mean, just by changing some compiler optimization levels, you can get already different speedups, yeah. And so it's additional complication when you want to compare different compilers on different systems.
Thank you very much for the question. That's actually interesting because in our Cocos code variants, in our compiling, we do specify which architecture we are going to be using. And Cocos handles most of the optimizations. Like we didn't go too deep into this compiling with Cocos. While on the OpenMP baseline versions from our previous work, we did use the flags that are like the compilation flags that are special for OpenMP and its optimization, especially on the CPU baseline version where we had the best CPU performance with BS Ultra. That one used special vectorization instructions for AVX 512 instructions, and so that makes that gives some better looks into Cocos. Thank you.
Thank you for your presentation. It was really interesting. I have a question regarding the metric of application efficiency. Is it proposed by your paper, or it comes from somewhere else?
No, the application efficiency metric also was proposed by Pennycook and his work, where they proposed the performance portability metric. They also proposed other metrics. We wanted to explore architectural efficiency, which considers like the theoretical peak performance achievable by each device. But this was complicated because it doesn't seem to be standardized when the vendors tell us how many flops their devices or their CPUs achieve. So we have actually been exploring on performing like benchmarks that help us set what our architectural efficiency theoretical peak would be. So yeah.
Thank you. Well done.
Thank you.
Okay, let's thank the speaker again. Okay. Professor. Our next speaker is Professor Sergio Nesmachnow. Pronounced okay? Nope. Okay. From Universidad de la República. And he's going to talk about high-performance computing for supervised machine learning training, parallel distributed implementation of the word-to-vector algorithm for training word embeddings. Do you prefer the moving? Yes.
Okay. Hello.
This is the last talk, I think. Oh, just before the Matteo Varelo award ceremony and the gala dinner, so I promise to be very quick. So this is a work from my students, Rafael and Ignacio. And I remember the old days when the students came to make the presentation to the conference. Now they send the professor and say, "Wait, present by yourself." So, yeah. May I have the ice here? Okay. Thank you. So, the word deals with embeddings that are vector representation of words under the hypothesis of that the closed embeddings are somehow referring to close meaning of this word in a corpus of text. The fact is that computing this embedding requires a vast amount of processing data and also computationally intensive tasks. But this embedding has high application in technology, especially in natural language processing, which you know it's on the rise on the last years. I don't know why, but I can ask ChatGPT, of course, for the popularization of generative models for text, in which embeddings are an important part of it. So the proposal of this work was defining a parallel distributed method for training word embeddings over a commodity cluster infrastructure. Yeah, the traditional network of workstation in the campus of our faculty. So the students are doing the final engineering project on natural language processing, and they face this problem that is taking so long to train the computational intelligence method that they use for, well, defining the generative model they are using. So they wanted to harness the power of existing computing infrastructure in our campus. Well, this problem of learning word embeddings is very important, and the main idea is to capture the semantic and syntactic relationship between the words, taking into account the information on the context. So the idea is to associate the words that are defined on the vocabulary, that is a high dimensional space, to a lower dimensional space that is a number representation, which is in fact the embedding. The idea, and we will see in the next slide from the algorithm, is the distributional hypothesis. Then closed words in the text are highly, has a high probability of having a similar meaning or a close meaning. So this approach makes the textual information useful for many machine learning algorithms. So this is the main relevance of the topic. The algorithm they parallelized is word2vec. We work on this underlying principle, which I already commented about, that words appearing in similar contexts are likely to have similar meanings. And it's a self-supervised approach, which use a binary classifier, and we will see the pseudocode in the next slide, and use a context information defined by a window size, a variable window size, and also negative samples as input for the classifier. So this is the main algorithm, and we can see the 3 main steps of the algorithm, which is iteratively applied for each word in the text. The first is to identify the content works to define the positive samples for the classifier. The second is pairing the target word with random words from the vocabulary as negative samples from the classifier. And then we have a classifier which is trained. The basic classifier is typically a logistic regressor, but other models, more corporate models, can be applied too. So as you can imagine, this for larger corpus of text, this is a highly demanding computing task to perform. So this is the main problem that they faced within their final engineering project. So they took our HPC course and came with this interesting problem to design an ad hoc procedure for computing the embeddings. This procedure is a client-server implementation, following the data parallel approach, using
parts of the text to be processed and analyzed on demand. They apply the client-server architecture, but also taking idea for a hierarchical master-slave architecture, in which the sub-server is responsible for receiving the request and then assigning the processing the chunks of text to process for each slave, and also following an active model. Yeah, the server also processes a small part of the text as long as he's idle accepting requests. This is a simple approach, but yet powerful. That does not require including more sophisticated logic, which of course can be included for example, scalability. And here you have a diagram, and we can see the two main parts of the server, which is the processing and the active model. And here are all the work management and monitoring duties, because as we will see in the next slide, the server is continually checking the status of the computational infrastructure and also the status of the clients that are performing computation. For the data distribution, the implementations apply a hash function, lightweight hash function, to lower data communications, and also to make more simple the mechanism for send and receive operations. For the data assignment, a simple approach, taking into account granularity estimation that I will show on the next slide, is applied. And as I told, the server applies an active model. Here, the server also processes the shorter chunk available to process to prioritize workload allocation duties. Two strategies were applied for load balancing: the best fit that tries to minimize the gap between the assigned load and the target load, and a first fit that also applies a simple approach, selecting the shortest suffix, such the cumulative weight of all documents or text to process is at least the target load. In preliminary experiments, the first fit allowed a proper load balancing, so it was adopted for the experimentation. Well, here is the granularity estimation. This is an important part of the incremental approach that the students developed. There is suited for heterogeneous clusters, in which the file-based assignment takes into account the target file weight and also the available computing power. The file weight is used because there is a strong correlation between the file size and the number of tokens, as shown in that graphic. But the more important part is this incremental model that the student implemented. This is an approach to use the less intrusive, yeah, the less intrusive way, the existing infrastructure without disturbing the processing of other users. So the system is able to add or review or remove computational processes on demand, subject to availability of the computing infrastructure. So the main idea is to have no interference with existing users, and is defined by setting threshold for creating or sleeping processes, taking into account two main criteria for workload estimation. There is the CPU utilization and the memory utilization, and applying two methods for load forecasting for the next 10 minutes. An ordinary least square and a most powerful forecasting method applying neural networks, which in fact was used in these experiments because it was 12% better accuracy than the ordinary least square. The main goal of all this schema is to perform the well-known CPU stealing, take advantage of the existing idle CPU cycles when there is no one using the computer or the user is making a suboptimal use of the computing resource. So the performance evaluations were performed using the full English dataset from Wikipedia. This is a larger corpus of text with more than 7 million articles, more than 5 billion words, etc. We use a small instance for for the initial experiments, and then larger instances varying the embedding size for the scalability analysis. Here we have some sample results, and we can see the execution time diminished up to 16 computational resources. And of course, up to this point and so on, the joining time has a significant overhead, which makes the model useful for up to 16 or 20 computational resources. Regarding the speedup and efficiency, we have to use an adapted version of the speedup, because you must take into account that the processes will be executing or sleeping if the threshold of the user, of the CPU used by the user, is achieved or not. So we have to take into account how much time the process is effectively using that resource, and use a weighted approach for defining the speedup. Where here you can see the result that corresponds to the previous slide. The maximum speedup was about 10 when using 16 CPUs, but a low, here you have, okay. The peak is at 16 resources, but the efficiency values were low. But that was for the small instance. For the larger instances, we see a more smooth declining of the computing time, with a lower impact of the joining time when these are the results are for the embedding size 100. Here we have this, sorry. Here we can see the reduced impact of joining overhead, which starts to reduce the speedup values up to 20 or 24 nodes. 24, yes, 24. Here is the summary of the efficiency results. The complete results are on the article. And you can see that the speedup increase for the larger problem instances when using larger embeddings. And here you have the efficiency values. This is a reasonable efficiency. And this efficiency is lower because for this instance, the best speedup was achieved when using 24 computing resources. This is a good efficiency value, taking into account that the resources are not used exclusively by the algorithm. Yeah? This parallel algorithm is competing with the resources from the users of the network of workstation in the campus, in our campus, in our machine room. So I think this is the main result. The student faced a specific problem and solved it with applying HPC. And they were able to execute anonymously on the local infrastructure of the campus. Less than 5% of the time they executed over the defined overhead. So there is a correct pattern of interaction with the real users that are in front of the machine. And the incremental model shown a correct creation of new client when resources were available. So the students were successful thieves. Well, not like this guy, of course. He steals personal data. No. My students steal CPU cycles that are idle on the computer lab. So that's all. This is the main conclusion, the parallel distributed implementation of the word-to-vector algorithm that achieved good efficiency values and successful CPU stealing on a shared computing without the G infrastructure. And of course, if you have any doubts about the presentation, you can email the students, which will be on that beach right now, taking a good bath of sun. And thank you very much for your attention. No. No, not him.
Well, this presentation is awful. Well, I have a couple of questions, simple ones. Yeah. Are you using the machines you are using? There are logical threads or only using the CPU cores?
This is not multi-threading, yeah?
Yes.
No, not multi-threading.
But the
single thread.
But you are running in only one instance, only one thread in one machine?
One thread in one machine. We don't want to interfere with the user. The user is in front of the machine. If we use the full thread for all of the time,
so you are running while the person is using the workstation. You are CPU still in the workstation, not nodes in the cluster or something like that.
No. This is not running the cluster. This is not running
across
a
the
cluster.
campus.
This is on existing infrastructure, a shared infrastructure.
Okay.
If we launch a 4-thread on a 4-thread machine, immediately the user will say, "Oh, this is slow."
Of course, and the machines have the hyperthreading enabled?
No.
They are only physical cores, so
physical.
they can affect also.
One process per machine.
So you don't have a way to measure the impact of running on the CPU or on the workstations, because this depends on the user. You know, you don't have a work running on that workstation, and you can measure before with.
This
or
is
without.
why I mentioned that we have to use a modified version of the speedup,
it's difficult,
taking into account all these details. For example, how much CPU is using the user to define the threshold and things like that.
Thank you.
Any more questions, comments? Oops, very far away. Okay.
So you are invited to that beach.
Thanks for your presentation. Are you thinking about another kind of word embedding instead of word to vec? For example, glove or fastest?
Yes. Thank you.
Or which is used in, or the difference between training this or implementing your method in these other word embedding algorithms? It could be the question.
Okay, and that is a very relevant question, because I'm not an expert on natural language processing. In fact, the students know more than me on that domain, but the approach they developed is applicable to any other word training embedding algorithm, in which you can split the load, and train the finite classifier using samples independently one of another. Because here the sliding window scheme for defining the context word is independent one of another. You can use different sides of the window, and you can define different instances for training, but there is no relationship. The only relationship is when you have to join the results to compute the accuracy and design a better classifier from the different classification that was performed by the clients.
Okay, so let's thank the speaker again and all the speakers from this track. Thank you very much.